video, I want to walk through each of the programs quickly that were created as part of phase 4 to show that they are actually fully functioning. All of the circuitry in this works. Everything works as expected. So I'm going to jump back over to BB Edit, and we'll start with the first one, add two numbers. So this assembly language, again, I walked through what I'm doing here in detail in the Word document, but I've already taken this and pasted it over here, and you can see that it's generated this hexadecimal language, or hexadecimal values for this program. And very briefly, what we're going to do is these programs actually use a couple of reusable subsections that I wrote that we jump to and return from to gather input and print output. So this get input basically waits until the user hits an ASCII value that is numeric. It concatenates those, or doesn't concatenate, it adds the digits together that the user enters up to 3 digits, and then writes them back to register RC and returns to the calling application using this ajump command that I have down here at the bottom, right here. So what I'm doing in my program is set register RE to a label value right here, and then jump to get input. When get input completes, it returns to whatever's in that register value, which happens to be this next command, where I get the next input, and then I do some simple math, add the two operands together, then jump to this done print. We print out the word done, and we also print the addition of those two values. So to see this program in action, I've already gone over here and add two numbers. I've already pasted that ROM, which you can see here. This ROM lines up exactly with what was here because I just pasted it. So I'm going to go into Logism, click on my ROM module, open it, and then scroll down to add two numbers, close. I've already got the simulation reset, so I'm going to enable simulation. Now basically I can enter a up to 3-digit number, 1, 2, 3 plus 10 should, and I'm going to hit enter, and that should equal 133. What about 12 plus 24? Should be 36. All right. 101 plus 102, 203. All right. So the next program I'm going to demonstrate is this keep adding numbers program. Same thing. Here is the keep adding numbers assembly. It's very similar to the add two numbers. The only difference is we ask for one input in the beginning, and then each additional input we just add to the prior value, and it continues adding until you hit 0. And if you hit 0, it'll restart the program again from the beginning. Go back through the same process. So again, this I've already compiled this ROM, or not really compiled, but assembled this ROM, adding, let's see, that would be keep adding numbers, and then we're going to start the simulation. So let's say, what is 12 plus 13? 25 plus 25, 50 plus 12 is 62 plus 100. All right. What is 123 plus 10 plus 20 plus 35? Now when I hit 0, it ends. So I'm starting over that's the part I didn't mention earlier, but 101 plus 10 is 111 plus 12, 123 plus 10. You get the idea. All right, so for the next program, that would be adding twos. This one's fairly simple. Again, we are reusing, in each one of these, I'm reusing the get input and the print commands. So all this does is get an input and then add 2's to it 10 times and print out the output. It adds a little dot right here for each iteration of this loop so you can see it adding. And go to Logism, open up that ROM. That is adding 2's. Close. I'm going to reset my simulation and then enable it. So let's start with the number 1, 1, 2. Oh, this is the wrong simulation. Let me try that again. So I'm going to open up adding 2's and then reset and start my simulation. 1, 0, 1. There we go. So each one of these dots represents one of the 2's that added. Obviously 101 plus 2 10 times is 121. 1, 1, 2 plus 2 10 times, 154, etc. Okay, so then the next program was, we showed keep adding. I showed add 2 numbers, adding 2's, shifting bits. So for shifting bits, I added a new subsection. I'm calling it subsection instead of function because it's not really a function, but it prints a number in a register as binary output, so you can see it in binary. So what this program does is you enter an input, it checks to see if it equals 8 ones. If it does, it says ones, and then lets you start over. Otherwise, it starts shifting the bits right, printing it out each time, and as soon as the least significant bit is 0, it stops and says LSB equals 0, and the program ends. You can restart the process from the beginning. So this ROM is here. Adding to keeping numbers, shifting bits. So with shifting bits, reset, enable our simulation. I'm going to start with a simple number, let's say the number 13. All right, there it's shifting the bits. That's 13. There's shifted right once. Then we hit LSB of 0 and we stop. What about 254? Oh, it stops right away because the least significant bit is 0. In fact, you get a lot that stop right away. But what about 255? Oh yes, that's ones. Okay, I'm going to get clever now and write 127. There's a lot of ones in that one. So there you can see the bit shift, shifting right process, and that is working as expected as well. I hope you enjoyed taking a look at how these programs work with my 8-bit CPU. In another video, I might walk through the CPU, but we also have the diagrams in the document and details on how the programs work.